Good morning, everyone, and thank you for joining me here today on the 13th International Conference on Information Intelligence Systems and Application. I am Christos-Panagiotis Balatsouras, and I will present you the work entitled WiCHORD, a Chord protocol application on a P2P LoRa wireless sensor networks. This is a joint work from me and also done alongside with Aristeidis, Karras, Dimitrios, Tsolis, and Spyros Sioutas from the Decentralized Systems Computing Group at the Computer Engineering and Informatics Department at the University of Patras. So, in that presentation, a brief introduction will be made to the context of this paper in order to define some concepts. Next up, I will briefly review some preliminary work of this paper in order to make this algorithm possible. And then the main part of the presentation will be about the presentation of the proposed methodology of this work, in order to finalize the presentation with simulation results and further directions of this work. First of all, I would like to say that in the modern era of Industry 4.0, there is a growing need for interconnected devices in order to support various applications. And that's why the IoT technology is here to bring the internet connectivity from computers to any device possible. This paper focuses on the wireless sensor networks concept from the range of all IoT applications. A wireless sensor network is useful in monitoring local conditions in an environment and consists of some sensor nodes randomly deployed on a field. These nodes consist of a microcontroller board connected to various sensors, and they communicate with each other in order to relay the information that they collect to the user via a cloud application. In order to make the connection on the network between the nodes possible, we use either short-range or long-range communication technologies, like short-range such as Wi-Fi or long-range such as LoRa communication technologies. And for this work, LoRa is selected among other LP1 technologies because it is cost-effective, it is license-free, and it can support long-distance communications in an energy-efficient way. So the goal here is to find an algorithm in order to connect a such network. And what we did here is that we proposed a new routing algorithm for sensor networks based on the Chord protocol from distributed hash tables. And with this work, we utilized the basic operations of Chord in order to support the node lookup queries and to keep the network running while some nodes may join or leave the network. And as I said before, LoRa is a long-range wireless technology supported and provided by LoRa Alliance. The range of LoRa in rural areas can be up to 20 kilometers. And the energy consumption is very low, and depending on the configuration of the network, we can have a node that its battery may last for months, even years, depending on the configuration and the energy configuration. And as I said before, LoRa is license-free, and in the European Union and in Europe to an extent, it uses the frequency band of 868 MHz. That's why we chose it for this work. And the Chord protocol was originally proposed by Ionian and others, and all the others, back in 2003. It is a distributed hash table in which each key is mapped on a certain hash value on a fixed circular n-bit hash space. And the hash space contains keys and nodes, and each key is mapped to the successor node based on its hash value. This is the basic principle of Chord, that each key is mapped to the successor node. And as I showed it here on the key with ID of 60, the hash value of 60 belongs to the node with ID 64. The basic functionality of Chord is the lookup query, which returns the responsible node for a key, for a requested key, and also Chord can maintain the stability while nodes join or leave the network. And now I will begin explaining the proposed methodology of this work. So this is the main part of the presentation. First of all, I would like to define some concepts that we will use later on in the following slides. The sensor node is a single node in the wireless sensor network consisting of a microcontroller unit, such like this one, on the image right there, and the various sensors connected to it, and the transceiver module and the battery. This is a device that acts as a sensor node. And this device relays all the sensor readings to a gateway node. The gateway node is the same device as the other ones, but it has internet access and can forward all the received information to the user via a cloud application. And this is the architecture of a network that will build the Chord protocol on top of it. On that figure right here. So the proposed wireless sensor network considered to be consisting of sensor nodes running and deployed on a large field. That's why we use LoRa. And the nodes are using LoRa to establish a link with each other. Each sensor node is only aware of a few other nodes on the network, while at the same time, all the nodes of the network are in the LoRa wireless range of the gateway. So they could possibly communicate with each other at any combination, but each node has the ability to know about a handful of other nodes on the network. And one network at a time can be acting as the gateway, and if that node fails, another node is elected to replace it. Proceeding to the methodology, I will now present you the modified Chord and all the interventions made to the original Chord protocol in order to be suitable for wireless sensor networks. The main motivations of choosing Chord in the wireless sensor network scenario are the following. First, Chord maintains stability when nodes join or leave the network. This is very useful on a sensor network because nodes rely on batteries for power and they are deployed in some fields that they don't have a continuous power supply. And also the lookup operation of Chord can be utilized to efficiently locate a specific node on the network in order to know where it is and if it is alive and running. The modified Chord has the same structure as the original Chord with these interventions done on it. So we keep the circular m-bit fixed hash space. Each sensor node on the wireless sensor network acts as a node on the Chord ring. But in contrast to the original Chord, only nodes are mapped on the circular hash space. We don't have keys assigned to each node. And we don't have keys because we don't want to store keys. We just want to use Chord in order to find and locate a specific node in the network via the usage of the Chord protocol. And each node is assigned with a unique ID on the network by hashing its MAC address with the SHA-1 algorithm. And every node on the network is only linked with its successor and predecessor nodes on the ring, alongside with some other nodes that also known as fingers, as you can see in the figure right there. And this figure shows an example of how to calculate the contact list of fingers for each node. It is calculated using that formula over here, which is taken from the original Chord. It is the same. If a sensor node is intended to join a network using the modified Chord, each MAC address is hashed to calculate its ID. The finger table of that new node is populated, and then on the network, some other nodes have to update their finger tables in order to include the new node in the Chord. As I said before, no keys are transferred to the new node because we don't use keys to store data on the Chord. The original Chord was a data structure and it's a hash table and it was used to store data, to distribute data to nodes. But we only use it to locate the nodes on the network. And when a node is about to leave the modified Chord, the leave operation notifies some other node that was previously linked to that node to remove it from the finger tables. And the leave operation is considered as a separate function on the modified Chord in difference with the original Chord, which uses a scheme of maintaining the stability of the network by periodically checking if the basic principle of Chord is fulfilled and if the nodes are alive. We use the leave operation to initiate a node removal process if a node is intended to leave because its battery is getting low. The lookup query on the modified Chord is used to find the corresponding node on the network, as I said before, for a given MAC address by performing the following. The given MAC address is hashed using SHA-1, and the hashed lookup value is passed as input to auxiliary functions, the same functions as the original Chord and the same mechanism used by the original Chord, in order to determine the corresponding node, the node that has the MAC address that we request to find. On a network of n total nodes, the length of the routing path to a lookup query is most likely to be O log n. And now I will present a scenario of how to apply this modified Chord algorithm on a LoRa wireless sensor network. And on this network, each sensor node and the gateway are LoRa enabled. Sensor nodes are deployed in a large area for monitoring purposes, if we want to monitor the spread of wildfires in the forest or any other example. And while sensor node only knows about the shorter nodes, all nodes know some fundamental characteristics of Chord, such as the ID of the Chord network that they belong, and the size of its fixed hash space. They know these fundamental specifications in order to communicate with each other. But this is the only information that is passed to all nodes. When a lookup query reaches the destination node, if we execute the lookup operation, the sensor measurements return back. They are combined in a reply message from the destination node and return back to the original node via LoRa directly. So we don't know where that node is on the network and if it's alive. So we select another node for the gateway to perform the lookup query of the node that we request to get the data from. This node locates the requested node on the Chord network using the Chord process, and then when the two nodes reach each other, they both know the IDs of each other, and the return message returns back to the sender directly via LoRa, because all nodes, as I said before, are in the LoRa region of the gateway. When a node is ready to join the modified Chord, it broadcasts a hello message to start the join operation. And when a node is about to leave the network, it broadcasts a departure message in order for the other nodes to remove it. And if a node is intended, these messages can be broadcasted only to one node, and then the process is starting via the Chord routing algorithm until all nodes are updated. Because the other nodes are communicating with each other to remove or to add the node to their contact lists, to their finger tables. If a node is and to build the Chord sensor network over LoRa from scratch, we also implemented a new build operation in which the gateway scans for hello messages in a certain frequency and then calls the join function recursively to add all these nodes to the network. In order to evaluate this modified approach of Chord, we developed a simulator using Python programming language. On the simulator, we implemented the nodes and the network as a Python class with the functions within each class. The node of the class had the function of join, leave, lookup, and build. And the network had the function of build. For the experiments, a sensor network of nodes with random MAC addresses on the simulator using the modified Chord is generated, and on that network we perform random lookup queries in order to measure the lookup routing path length in node hops. So we wanted to know how many hops from the nodes on the network are going through in order to resolve a lookup query. And on the conducted experiment, we tested different sensor networks, random networks on the simulator with different sizes of with different node populations, so with different total nodes, number of total nodes, and we performed some lookup queries on each of these networks, and then we calculated the average lookup query path length for each network. And we combined all these results to that plot over there. And afterwards, we had the results. The experiment showed us that the lookup query needs all log n hops as theory suggests. And you can see in this graph over there that it follows a logarithmic variation as the network size grows, as the network size growing bigger. The further directions of this work include the extension of the proposed methodology and the deployment of these algorithms on a large-scale LoRa network in order to experiment with a large set of nodes, and also an investigation in terms of energy consumption for this modified Chord, because energy is very crucial on IoT applications, especially when nodes rely on battery for their operation. Thank you for attending this presentation. I will be very happy to answer all of your questions.